This is a video for MEI Core Pure Mathematics, Hyperbolic Functions 1, 1.3, Hyperbolic Function Identities. We've already met this identity that tanh x is identical to sin x over cos x, and by identical we mean that this is true for all values of x. So let's look at what happens when we simplify this expression. I'm going to use the e to the x form for both functions, so e to the x plus e to the minus x over 2 squared, and that's take away e to the x minus e to the minus x over 2 squared. Multiply that up, I'm going to get a quarter e to the 2x plus 2 plus e to the minus 2x, take away a quarter of e to the 2x minus 2 plus e to the minus 2x. Gathering those together, quarter can come out as a common factor and I get e to the 2x and a minus e to the 2x there, and an e to the minus 2x and a minus e to the minus 2x there, so they all go, and I've got 2 minus minus 2, so I get 4. So that comes out to be 1. So cos squared x minus sin squared x is 1. That's an identity, it's true for all values of x. And just for a second, think about this one. Which we know for trig functions. These are very similar. The only difference is the sign here. So very similar identities, watch out for the signs. There's that worked through for you, and you can see we come down to this identity, and we will use this identity a lot, just as we do with cos squared plus sin squared. So the two key identities for us, tanh x is sin x over cos x, and cos squared minus sin squared is equal to 1. Okay, let's have a look at this identity. Can I show that that is true? Well, if I start from the right-hand side, cos squared x plus sin squared x, and if I rewrite those in terms of e to the x, so I've got e to the x plus e to the minus x over 2 all squared plus e to the x minus e to the minus x over 2 all squared. Multiply that out, I get a quarter, just as before, e to the 2x plus 2 plus e to the minus 2x, and this is plus a quarter this time, e to the 2x minus 2 plus e to the minus 2x. And this time I think you can see it's the 2's that are going to cancel and the others that are going to double up, so I'm going to get a quarter 2e to the 2x plus 2e to the minus 2x, and this is just e to the 2x plus e to the minus 2x all over 2, which is just cos 2x. And again, I want to think about cos squared x minus sin squared x, which is cos 2x. So a similar identity back in trig functions, the only difference being, again, a change of sign in the middle, plus and minus. So, can we use some of that to solve an equation like this? And the answer is yes, of course. Just like we would with trig functions, we'd do something with the cosh squared to get it in terms of sinh. We know that cosh squared x minus sinh squared x is equal to 1, and so we can write that cosh squared x is equal to 1 plus sinh squared x. Plug that into here. 3 lots of 1 plus sinh squared x minus 5 sinh x is equal to 1. Let's multiply that through then. And I'm going to bring the 1 over as well. This will boil down to a nice little quadratic in sinh. So 3 sinh squared x minus 5 sinh x plus 2 is equal to 0. That will factorize into 3 sinh x minus 2 and sinh x minus 1. And that gives me that sinh x is equal to 2/3, or sinh x is equal to 1. Now you can use calculator inverse hyperbolic sine to get that x is equal to 0.625 or x is equal to 0.881. And you might like to check that you can get those results from your calculator. There it is worked through for you. So there's the replacement of cosh squared with 1 plus sinh squared. You get the quadratic, which then factorizes, and your 2 results here. The next and final video in the sequence is 1.4, differentiating and integrating hyperbolic functions.